particularly trends in atomic radii of transition elements. So from this, there is a possibility of one question. One question maybe you may be getting from this. So what is that question? What questions are possible from this? The most of the questions revolving around this lanthanoid contraction only from this transition elements. Most of the questions, the lanthanoid contraction, because the lanthanoid contraction will affect the properties, physical and chemical properties. Okay. Particularly atomic size, particularly ionic radius of the transition elements. Now here, so three series of transition elements are there. One is 3D series and 4D series and 5D series of elements. Now, if you want to know the trends in atomic size of the 3D series, 4D series, 5D series of elements with increasing atomic number, how the atomic radius will be varying. Atomic number is taken on where means on the x-axis, okay, and atomic radius of the elements taken where means on this y-axis. Atomic radius is measured in terms of picometers, so in terms of picometers we say, okay. Now can anybody define what is meant by atomic radius? What is atomic radius? Can anybody tell? Can anyone define what is meant by atomic radius?
So it is the distance from the center of the nucleus to the outer orbital.
So atomic radius of an atom is the distance between the center of the nucleus to outermost electronic cloud, right?
Yes, sir.
The center of the nucleus to outermost electronic cloud is said to be atomic radius. So atomic radius from left to right, in 3D series or in 4D series, increases or decreases? Atomic radius from the left to right in the periodic table decreases or increases. Already we discussed in that yesterday class, in the previous class, due to lanthanoid contraction, right? So now here in this graph, look at this, increasing atomic number on this x-axis and increasing atomic radius on this, so y-axis is taken. Now first element, so and take this atomic number starting from how much means here 21. 21 is the atomic number of what? Scandium. See, here is a scandium. So the starting atomic radius, how much? 160 picometers of the scandium. So after that, so atomic number 22 is the titanium. Atomic number, so vanadium 23 and the chromium. See, decreasing of this atomic radius with increasing of atomic number, chromium. And again, so further decreases manganese and iron, cobalt, nickel. And after that, slight increasing of this, so copper and zinc. So here is. What possible question do you get from this? So here, why this atomic size decreases across the period from the left to right? So what could be the reason? Can anybody suggest why this atomic size is decreasing in 3D series? So across the period from left to right. Yesterday I told.
So effective nuclear charge.
Increasing of effective nuclear charge. And what else? Other reason?
So only due to the shielding.
poor shielding effect of d orbital and poor shielding effect of what means so f orbital, right? So or do we say imperfect shielding effect of so d orbitals or f orbital we write. So imperfect shielding, and due to that nuclear charge over this outermost electron will be more, then then orbital will be pulled toward the center, then the size of the atom decreases. So this is the reason we can tell, means increasing of atomic number. So atomic number increases, atomic size decreases due to Lanthanoid contraction. So and one more concept here we have to talk about. If the atomic size decreases from the left to right, so the atomic mass also increases, no? Atomic mass increases, and due to the increasing of atomic mass, density of the atoms also increases. That means, so from the 3D series, which element will have more density? Can anybody tell? So in this 3D series of elements, which element has more atomic mass, more atomic density? Because atomic volume of this scandium is greater than atomic volume of the zinc, no? Less is the volume, more is the mass, density is more, right? So zinc has more density, and copper, these elements, so copper and zinc will have the more density because atomic mass increases, volume decreases. Clear, everyone? So the density or atomic mass will be more with this copper and zinc. Now look at this 4D series of elements. 4D series of elements starting from 4D series. Tell me what are the 4D series? First element is 4D series element is yttrium, yttrium after zirconium, tantalum, wolfram, rhenium, osmium, iridium, platinum. Okay. So gold, sorry, silver, cadmium. So this is the black line, you can check, black line. And one more 5D series of elements, lanthanum, hafnium, niobium, wolfram. So this is a rhenium. So technetium is that 4D series, rhenium is that 5D series, osmium and ruthenium. Osmium is that 5D and ruthenium is 4D. Iridium, platinum, gold, mercury. See, what observation do you make from these three lines? 3D series line, 4D and 5D series are almost all overlapped. Can anybody tell what could be the reason? Atomic radius of 3D and 4D almost all, sorry, 5D and 4D almost all. 4D series of elements, 5D series of elements, almost all overlapped. What same? What could be the reason? Can anybody tell? Are you listening to me? What I'm speaking?
Yes, sir.
Yes, sir.
See, if you observe the 4D series of elements, 4D series of elements if you observe, and 5D series of elements if you observe, so their graph is, so almost all their atomic radii of 4D and 5D overlapped, means very close. Their atomic size is very close, almost all same. their physical properties, their chemical properties almost all same as you compare with the 3D series. Then what reason you will suggest for this? What could be the reason? Why not? This is 3D series and 4D series, there is so much far away. But 4D series and 5D series, their atomic radii. So when atomic radii increasing, atomic radii decreases with increasing of Z value. When Z value increases, atomic radius decreasing. So in 3D and 4D series. For example, check this zirconium, hafnium. So the zirconium and hafnium, almost all atomic radius is very close. Even you can see tantrum and niobium also, wolfram and molybdenum also. Okay, and gold and silver also. Their atomic size almost all close resemblance. So what reason do you suggest why these 4D and 5D series having close resemblance with and then the 3D series? No reason? That means lanthanoid contraction is more significant in 4D series and 5D series than the 3D series, because in this 4D series and 5D series, F orbital will start, no, sorry, F orbital will begin. So lanthanoid contraction is more significant in 4D series and 5D series, more significant and more imperfect shielding of F orbital. So in these elements, so that could be the reason. Clear everyone? That means atomic radius from left to right decreases due to the reason. What is the reason? Means due to increasing of effective nuclear charge, number one. Number two, poor shielding effect of d orbital and f orbital present. So if you compare the f orbital shielding effect is very less than the d orbital. If I give the two orbitals to you, so which will shield the nuclear charge? D orbital more than the f orbital. Can anybody tell the reason why? So f orbital has a less shielding effect than the d orbital. Because the structure of the f orbital is dispersed shape, diffused shape. Because of that reason, poor shielding effect of f orbital will causes more lanthanoid contraction. Clear everyone?
Yes, sir.
Yes, sir.
And one more here. So lanthanoid contraction. See, the question will be, so zirconium and hafnium. So because zirconium and hafnium will have the same atomic size, their extraction methods are same. So very difficult to prepare, difficult to isolate this zirconium and hafnium from their minerals. So because of the small size or because of this similar atomic size, we say. And as we move from the left to right, atomic mass increases, and at the same time density of that element also increases. Note down this point also. Okay, now I am moving further, and one more here important point. There are elements zinc, cadmium, mercury. At the extreme right, these elements have the complete field electronic configuration. So 3D 10, 4D 10, 5D 10. So these elements will exhibit so different properties as you compare with so which elements as you compare with this rest of the transition elements. So what is the different property means? So zinc, cadmium and mercury, they can exhibit so soft property, volatile property they have. Zinc, cadmium, mercury. Already you know mercury is the metal liquid at the room temperature. Cadmium also very soft, and zinc also soft metal as you compare with the copper and silver. So they have volatile property. They have the volatile property. So because can anybody tell what is the reason why the mercury, cadmium, zinc has the volatile property, soft property, whereas the other metals like silver, copper will be very hard metals? Can anybody tell the reason? Anyone? Why the zinc? Do you understand what I'm talking about? Why zinc